Alright, this video is the first part of factoring trinomials. So I'm going to take a little while in this video to explain the way that I look at factoring, and then I'll have another video where I give some more examples after that. Okay, so first of all, I think of factoring like a big number game. Okay, and I like numbers, so number game to me sounds fun. So that's the way I'm going to think about this. Okay, so I promise I'm going to get to the point, but just stay with me. So let's say that I need you to think of a couple of numbers that will do the things that I'm going to mention. So I need you to think of two numbers that will add to be 7, but will multiply to be 12. Okay, so these two numbers will add up to be 7, but if I multiplied the exact same two numbers, then they would multiply to be 12. Okay, so if you think about that for a second, the only numbers that would do that would be 3 and 4, because 3 plus 4 would be 7. 3 times 4 would be 12. So as you're watching this video, if you need a little bit of time to come up with the numbers that will do the things, then just pause it before I give the answer. That way you have time to think of it before I tell you what they are. So say I need two numbers that will add to be 10, and they will multiply to be 16. So those numbers would be 2 and 8. 2 plus 8 is 10. 2 times 8 is 16. I need two numbers that multiply to be 6. Add to be 6. Multiply to be 5. Those numbers would be 1 and 5. Or two numbers that add to be 11 and multiply to be 30. Those numbers would be 6 and 5. Or two numbers that add to be 10, multiply to be 24. That would be 6 and 4. Okay, so that's what I mean by number game. We're thinking of numbers like this. They add to be something, but they would also multiply to be this other thing. Now let's change this just slightly. This time I want you to think of numbers that will subtract and multiply. Okay, so for example, I want two numbers that subtract to give me 4, but multiply to be 21. Okay, so those numbers would be 7 and 3. 7 minus 3 is 4, but 7 times 3 is 21. Or they subtract to be 3, multiply to be 18. That would be 6 and 3. Subtract to be 1, multiply to be 12. That would be 4 and 3. Subtract to be 4, multiply to be 12. That would be 6 and 2. Subtract to be 1, multiply to be 20. That would be 5 and 4. Or subtract to be 23, multiply to be 24. That would be 24 and 1. Okay, so whenever we are factoring, this is the way that makes the most sense to me, that if I'm factoring, I'm thinking about it in this way. So let me relate this to what we would normally think of as factoring. Let's say I have this polynomial, this trinomial, x squared plus 8x plus 12. So when I'm trying to figure out how to factor this number at the end, this last number, or my constant term, that's the number that I'm trying to multiply to get. So whatever my two numbers are, they're going to multiply to be 12. Now, notice before the 12, there's a plus there. Okay, that plus is telling me that I need to think of adding to get that middle term. So I need two numbers that multiply to be 12, but they add to be 8. So if you think about what those two numbers are, that's going to be 6 and 2. So when we are factoring a trinomial, we're going to end up with two parentheses. I know for now that this is both going to start with x, because x times x would give me x squared. And then those two numbers that we thought of, that's going to be what goes in here. And so for right now on this video, I'm only giving you examples with all positives. So everything is being plus. So I'm going to have x plus 6 and x plus 2. Okay. Now, the order of the parentheses doesn't matter. So if I were to write instead x plus 2 and then I wrote x plus 6, then that would also be right. Okay? So it doesn't really matter which order you write your two parentheses, just as long as you have those things. Okay, now in case you're wondering and you don't quite see how this gets you the right answer, think about if I were to take these two and multiply these back out. I would say x times x, that's x squared. X times 6, that's 6x. 2 times x, that's 2x. And 2 times 6, that's 12. And then we would add those two like terms there in the middle. 6x plus 2x gives us 8x. So x squared plus 8x plus 12. So that's how it works. Okay, so let's try another one. So let's say that we have n squared plus 7n plus 12. So this time I need two numbers that multiply to be 12, but they add to give me 7. So if we think about what those two numbers will be, that's going to be 4 and 3. So this is n plus 4 and n plus 3. Or remember the other way around, n plus 3 and then n plus 4. Okay? All right, another example would be if I had p squared plus 9p plus 20. So I need two numbers that multiply to give me 20, but add to give me 9. And so those numbers would be 5 and 4. So this is going to be p plus 5 and p plus 4. Okay, so we don't always have all positives. So if you need to see examples where you have different signs mixed in there too, then you'll want to watch part 2 of factoring trinomials.